Welcome to This Explainer. Today, we're going to break down an absolutely crucial cornerstone of modern environmental science. It's called the matrix method, and it's used heavily in environmental impact assessments. I am super excited to guide you through this methodology today. We're going to treat this just like a masterclass. We'll dissect the theory, look at the historical data, and then actually apply it step by step so you can see exactly how environmental professionals evaluate the world around us. Okay, let's dive right in. Here is our roadmap for today's explainer, starting with the conceptual hook and taking us all the way through a real-world case study and critical evaluation. Section 1. The conceptual hook, measuring the immeasurable. Imagine you're in charge of a massive civil engineering project. We're talking about a huge hydroelectric dam or maybe carving a multi-lane highway right through a valley. We have to ask ourselves a really fundamental question. How do we actually quantify the exact environmental cost of that project? Because, it isn't just about the financial budget or the tons of concrete being poured. When we alter a landscape, we set off a highly complex chain reaction. We're altering water flow, displacing wildlife, changing local economies, and impacting air quality. It's a lot. So how on earth do engineers and scientists effectively measure, track, and present this incredibly diverse human impact on nature? Well, we need a highly structured, scientifically reliable method. Which brings us to Section 2, Foundational Definition, the matrix structure. So to answer that big question, we turn to the matrix method. Put simply, this method provides us with a crystal clear, systematic framework to evaluate all these complex environmental interactions. By definition, it's a visual and analytical tool that illustrates the direct relationship between specific project activities, like, say, digging a trench or pouring concrete, and the potential environmental impacts those specific activities trigger. Instead of just a chaotic, unstructured list of worries, the matrix method forces us to be exceptionally precise about cause and effect. It's like a giant puzzle where every piece has to be accounted for. Think of a simple interaction matrix, almost like a giant spreadsheet. You form it by plotting the project actions on one axis, most commonly the vertical axis, against the environmental impacts or characteristics on the horizontal axis. Every single time a row intersects with a column, it forces the assessor to pause and ask, wait, does this specific action affect this specific environmental trait? This rigorous structure is totally brilliant because it actively prevents critical oversights. Section 3. Historical context. The pioneering Leopold matrix. Now, you might be wondering where this all came from. The matrix technique was actually pioneered way back in 1971 by Luna Leopold and his colleagues. And let me tell you, they did not start small. The original Leopold matrix was incredibly comprehensive. It essentially attempted to map out the entire scope of human engineering. The vertical axis of his matrix listed approximately 100 specific project actions. That is 100 different ways humans can physically alter an environment, ranging from basic surface excavation all the way to the application of pesticides. But it gets even crazier when you look at the horizontal axis. Those 100 actions were evaluated against 88 distinct environmental characteristics and conditions. So if you do the math on that, multiplying 100 by 88, you generate a massive grid of 8,800 possible interactions. That is 8,800 unique points of data where a scientist must evaluate potential environmental disruption. It was an absolute game changer, a groundbreaking leap enforcing rigorous, exhaustive environmental accountability. Section 4. Matrix deconstruction. Categories of effect. Before we look at a completed matrix, we really need to deconstruct the categories of environmental effects we're actually measuring. Modern standard checklists measure some pretty broad, crucial categories. On the physical science side, we're looking at things like changes in hydrology, meaning the movement and distribution of water, as well as impacts on soils, sediments, and overall ecology. But check this out. Notice the inclusion of socioeconomic factors and health. A truly rigorous matrix doesn't just isolate nature from humanity. It measures how the project affects human populations, our local economies, and our physical well-being, mapping out imbalances across the entire ecosystem, the whole shebang. Moving right along to Section 5, the Feet Suite Case Study, Application in Action. Let's see this theory put into practice. If we take a micro-extracted section of data from the Feet Suite Reservoir project, we can clearly see how this all connects. On one side, we have our project actions, building roads, blasting operations, and dam construction. On the other, our environmental features, forestry, water quality, and air quality. Let's trace an intersection together. If you follow blasting operation to where it intersects with air quality, you get a specific impact score of -1T. Or trace dam construction intersecting with water quality, and you get a -2T. Okay, but to ensure absolute technical accuracy, we really need to decode what these alphanumeric symbols actually mean in the real world. To keep things crystal clear, let's define these variables. Every single entry in the matrix conveys 3 distinct pieces of data. First up, the impact direction. Is it beneficial, which gets a plus sign, or detrimental, which gets a minus sign? Second, the impact scale. This is graded on a scale from 1, meaning mild, all the way up to 4, which is very high. Finally, the duration. Is the effect temporary, indicated by a T, or permanent, indicated by a P? So going back to our previous example, actually, let's just translate it directly. A score of -2T for water quality during dam construction perfectly translates to a detrimental, considerable impact that is temporary. This brilliant shorthand allows complex scientific consensus to be read and understood at a single glance. Section 6, Critical Evaluation, Strengths and Limitations. Any rigorous academic analysis requires an objective, balanced look at the method's efficacy, right? So let's talk pros and cons. The primary advantage of the matrix is its undeniable visual clarity. It explicitly links a specific action to its resulting impact. There is literally no hiding behind vague paragraphs of text. If you are blasting rock, the matrix demands you log a score for air and noise quality. It's an exceptionally effective visual method for displaying environmental impact assessment results to stakeholders, politicians, and the public, allowing everyone to instantly see the primary areas of environmental concern. However, as an academic tool, it definitely has some notable limitations that we have to acknowledge. First off, it's quite difficult within this simple grid to distinguish between direct and indirect impacts. Second, there is a significant potential for double counting. For instance, if soil is degraded, that might be logged as a negative impact on soils, but then it might also be subsequently logged as a negative impact on agriculture, which artificially inflates the negative score. Finally, and this is probably the most important point, it is inherently qualitative. A -4 is an expert's assigned severity score. It doesn't actually tell an engineer the true numerical quantity of the impact, like the exact parts per million of a pollutant or the precise number of acres destroyed. Which leaves us with a critical, concluding thought to ponder today. If the matrix relies heavily on the qualitative, human judgment of the experts filling it out, how do we protect our vital environmental assessments from subjective bias? How do we ensure that a -2 to one scientist isn't a -4 to another? It's a fascinating question, and it sits at the very heart of modern environmental engineering, reminding us that our scientific tools are really only as objective as the professionals who wield them. Thank you so much for joining me for this explainer. I hope it brought some incredible clarity to how we measure our footprint on the world. Keep questioning and keep learning.